changing one word in your prompt changes the probabilities of the next sequence. The biggest challenge with LLMs is trustworthiness. So it's not just model GPT-4 is less biased than Claude 3. End-to-end automation, complete automation is scary. Of course, language models are in fact able to assess and evaluate other large language models. You don't want to host a full precision of 200 billion model or anything like that.
Hey folks, welcome to the latest episode of Disrupting AI Experts Insights. Today we'll talk about large language models and their evaluation, discussing trust, transparency, and scalability. Our guest Oguz shares key insights from his 15 years of experience in AI, exploring how to address challenges like hallucination and bias while optimizing LLM performance. Let's get started.
Briefly introduce yourself and your role at Root Signals, and how does your background in AI and entrepreneurship, approach build this scalable and trustworthy LLM applications?
Sure. My name is Oguzhan Gencoglu. My background is in machine learning research. I started my machine learning career in the academia long time ago, 15 years ago. So back then I was writing research papers, machine learning papers specifically. It was very early days of deep learning. Nobody cared back then, of course.
Okay.
So it was a bit that sort of start. And then I co-founded one AI startup about 7-8 years ago, and we did an exit. We got acquired. Then I continued advising as a one-man company, different kind of startups, OECD AI, which I am still advising, different kind of organizations and companies in all sorts of AI problems, and not only strategic advising, also hands-on algorithm development. But then about one and a half years ago, I have co-founded Root Signals, and I'm head of AI at Root Signals. And at Root Signals, we are specifically focusing on trying to answer how do we measure LLM applications? How do we quantify all kinds of millions of LLM-powered applications and products are being built all day, every day. But how do we measure those, and how do we compare? How do we trust? How do we control? How do we guardrail?
I see. So from LLM application production, building an application, how does it evolve towards the evaluation?
I think very few people think these evaluations as the first step.
All right, yeah.
But we think that should be the first thing to be thought of. And it's not only about, so in our view, if you don't know your metrics, if you haven't decided your metrics, building something it doesn't go to production basically. So in our experience, most people are, because it's so easy to build something with LLMs nowadays. Literally lots of frameworks, LangChains, Llama indexes, Azure AI Studios, AWS, all kinds of tools, all kinds of open source tools, open source models are mostly just a couple of lines of code where you just make a call to Anthropic or OpenAI. So it's super easy to build stuff. And that's why people typically quickly start building some RAG applications, some Q&A bots, some chatbot, some translation, some summarization automation, and then ask the question, okay, but is this the best model to do this? Is this the best prompt to do this?
Yeah.
Is this the best kind of parameters for my embeddings and RAG and all that to do this? Then start to ask, hey, how do I measure this? Oh, it hallucinated. How do I detect these things? The answer is not that relevant, or it's talking a bit too much and it's revealing some confidential info. So I think in our perspective at Root Signals, you decide first what you want from this application, from this automation. And then once you do that, because we have the metrics, because we provide all the metrics and evaluations, choice of model and prompts. It's just optimization problem.
Invention basically comes with a manual. So if you don't have a manual, how will you actually, look for it, okay, whether it's working according to the given manual or not? Anyways, so starting from the challenges, what exactly the biggest challenge you're talking about when it comes to LLMs today? Are we still like
Uh,
fighting for hallucination or biases, or
yeah.
there are more pressing concerns?
I would say the largest, biggest challenge of going to like unlocking proper business value and going to production with LLMs is trustworthiness,
Yeah.
meaning hallucinations, relevance, all that stuff. Um, Costs are going down almost every month.
Yeah.
I don't think that's like a blocker. Uh, token costs are going down. Latency is not is not yet a blocker, so it's okay enough. The speed is okay enough, but people are like, hey, we can't expose this to the outside world because it just makes stuff up. And this property of hallucinations, it's not going to be solved. It's like okay, it will be solved for maybe the current problems we are working on, but we demand more complex things from AI, then it will hallucinate in those complex stuff. So this is an inherent feature of this technology, deep neural networks. They are kind of black box, and you cannot trace it. You cannot open it up and look. Okay, this is why it did. So this is like the fundamental issue. Uh, I think the challenge in LLMs and all generative AI.
I see, I see. So what basically the metrics do you find most critical for evaluating LLM performance in real world applications?
Yeah. Um, how I see this metrics is kind of two categories. One is really lower level metrics, low level metrics that machine learning nerds and people like me would care about. These are like perplexity, negative log likelihood, and this sort of boring things. And we, in our platform, in root signals, we don't think these are relevant. We think metrics that are closer to business, closer to real use cases are more relevant. And these are stuff like hallucinations. Did it hallucinate or not? Was it faithful to your documents in case of RAG? So faithfulness, truthfulness, answer relevance, but also other kind of a bit more abstract metrics. We provide these evaluators out of the box. For example, um, safety for children, uh, politeness, engagingness, helpfulness, uh, conciseness. You sometimes you want just a you don't want the model to chat. Oh, thank you. This is very interesting. I can just tell me the answer. So typically, lots of applications care about these things. Then maybe I can add another category of this metrics. It's like when we provide this, it's custom metrics.
Okay.
Different companies have their own domain knowledge. For example, our clients are in legal, are in pharmaceutical, healthcare. We are not doctors. We don't. They know what exactly they would like to evaluate their metric, and it's a custom thing. For example, some they would like to evaluate if the jargon is correct, or they would like to evaluate if LLM is responding according to their company policy. It's a metric. It's a metric. It's an evaluator. Like, is the LLM compliant with our? We have a company policy. It's in this
Yeah.
PDF.
Mm.
Is it compliant? So this is a very real metric. So this kind of higher level metrics closer to business, these people care or companies care about this a lot.
Okay. But all these goes back to the data set that you are feeding to the LLM. So if the data set is correct, let's say it does not have any fake or unnecessary information, so how come the model hallucinate or comes up with something which is not factually correct? What do you think? Well, it's
Yeah,
basically the gap that we
the
are unable
reason
to.
is, yeah, there's the technical reason because of that is these models are called autoregressive models, meaning that they are predicting the next token. This is how they work. So they basically
Sorry, yeah, go ahead.
no problem. So the reason for this, your question that, okay, even if we give really pristine data to the model, to the training, which we don't, by the way, because there's no such thing. But even if we have, if we do that, how come model is making stuff up, or how can the model can make stuff up and hallucinate? The reason is these models are autoregressive models, meaning they are predicting the next token. So they are finding the most likely token in a sequence of tokens, and the way you write your prompt changes, of course, the model answer. So essentially, there's no control on, when training these models. There's no control on this kind of accurate control on, okay, you need to learn this likelihood for this sequence of text and this sort of things. So there's no this kind of white box learning. You just put a lot of compute and a lot of data, and the model roughly learns representing that language. Basically, in this case, we call it representation learning. And after that, just changing one word in your prompt changes the probabilities of the next sequence. So there's no way to control if the model is giving the answer 5% or 10%, because in your data there might be, it simply might be that the likelihoods are learned that way and the value is hallucinated. So this is how neural networks or large language models work by design. So this is just how it is. So this hallucination is a feature, unfortunately.
It means like the process itself tend to hallucinate. We cannot control over it because, of course, the data is too large for a system to actually evaluate what exactly we're asking for. Anyway, what about the creativity element of the content? That if I'm putting up any prompt and asking ChatGPT or any LLM to give me a creative answer, again, creativity is a very subjective term. So how does this help, or maybe actually is something a metric in your evaluation process or criteria, that how do you rate creativity in responses?
Yeah, typically this sort of very, very subjective and context dependent metrics, they are evaluated in such a way that correlation with human agreement, because we are not evaluating creativity for some machine, but for a human's interpretation, because that's just how it is. It's subjective. So when you have when you build enough evaluate or correct or correlated enough evaluators with human judgment, then that's one way to do it. But that requires, of course, collecting human annotated data. So that's one thing. And another thing is that, of course, feedback is very important. If the user doesn't agree with the evaluator's score, these models are very open to learning with just from a couple of examples. So you can really, in context, even, hey, this was not good, like couple of annotations, and these are a couple of examples where you failed, and you can tune your metrics and evaluators pretty fast, compared to a bit more old traditional machine learning models where you had to bring hundreds and thousands of data points. So there's this two sides of things, that yes, it's subjective, but it's also very flexible, because you can quickly show a couple of examples and okay, it gets the high level concept.
Makes sense. So we're talking about the model drift and the performance degradation. How companies are overcoming issues like that when it comes to handling vast data sets at scale?
There are like couple of tips. One is, of course, our world changes. There's some we saw it in pandemic. all our models became wrong suddenly. It just all our sales forecast and
Everything, yeah.
optimization of train schedules. That's a joke, of course. So world changes, and then the data, of course, we sample from, or the phenomena we sample the data from changes, meaning our data drifts. So models drift in that sense because the input, the things people are demanding from these models, the questions, the instructions, the prompts change. And then we have optimized our applications for one kind of world, and now the world is in a different way. But there's another drift that if you are using proprietary closed source APIs like OpenAI's GPTs or Anthropic and Mistral and stuff, well, they can change. They are not going to ask you. They change things all the time. So so that's one other source of regression, that you are using GPT-4, but there's no guarantee, literally no guarantee, OpenAI doesn't change it today.
Yeah.
And your expectations, and they do change it, in fact. And I'm not talking about a new model, GPT-5 or something. They changed all the time, tune a bit, changed about the current models, meaning that you need to kind of test and evaluate all the time in some sense.
I see. So talking about the real-time monitoring of AI, in production environments, real-time monitoring is essential for ensuring reliability of AI models.
Yes.
So what tools or strategies you found most effective for real-time monitoring, and how can teams ensure their models remain accurate and unbiased? Of course, that is not be controlled overall, but again, to least accuracy and unbiasedness over time.
Yeah, in root signals, of course, we evaluate, then we have the observability and monitoring part, of course. What has been very useful based on our clients' feedback, customer feedback, is that we are pretty transparent about the users can go as detailed as they want. So all the way to what was the exact sent prompt, what was the exact instruction or question, what was the exact thing that sent to the model, and then these are the responses, and these were the scores of our evaluators. Oh, it hallucinated. So that being able to look at it, what exactly was sent, because some frameworks, they just abstract. You can't even say, hey, what was sent to what was the prompt? Just show me the prompt. So we don't have that way. So full transparency. Secondly, all our evaluators, they also return the justification of our score. So we return, okay, it has not just hallucinated or not, but why. And that's, of course, super useful for humans to look at it. And other thing is, of course, cost and this accuracy or answer quality, and cost and latency kind of matrix you can, because if once you have the cost and latency too, now people start to realize, hey, for this task, my evaluations show this cheaper and faster model is just as good. I don't need to use GPT-4 for everything, because why am I paying this much? It's like half the price. But you can only make this decision if you can evaluate. If you can't evaluate, you cannot switch, because you don't know.
You don't know
So
exactly.
this is exactly. So this is this accuracy, cost, latency, full picture. That's pretty crucial for all kinds of teams building these LLM-based automations.
Okay. So how do you address, like if talking about transparency, how do you consider, like, address concerns like bias detection, regularity, compliance, maintenance, like transparency? We have tools like IBM's AI Fairness 360. We have what if tools provide fairness, Google's, we have transparency support as well. So how does these protocols play a role in LLM evaluation or development?
I think many of these tools are out there. They are a bit, they are evaluating a bit in an academic sense, LLMs.
Okay.
And we are more interested in evaluating LLM applications,
Okay.
not just LLMs, because of course research people and all these companies are evaluating LLMs all the time, but it doesn't mean your LLM-powered application.
Okay.
It's not the same thing as evaluating your application, because you have lots of custom prompts, you have custom logic, you have your documents. So how I see this, this bias and transparency and hallucinations and answer relevance and all these evaluations, we think it needs to be specific to your application. So it's not just model GPT-4 is less biased than Claude 3 kind of, because those are LLMs, but how you use them, that changes those metrics completely. So that's why we are not evaluating LLMs, but we are evaluating LLM-powered applications that people are building. So that's one thing. That's one thing to say. And there's the I think what's important in terms of bias is that it's also contextual. Lots of our customers, they would like to define what they expect from this, because there's lots of dimensions of things can go wrong and lots of dimensions of bias, and sometimes they are in contradiction with each other. So there's a trade-off. You make the model fair in some sense, but it becomes unfair in some other sense. There are all kinds of things like that in the real world. And I think giving the control to define what they really care about, the metrics, that's been the strategy for us. So there's lots of compliance evaluations, but which ones they care most? Is it the EU regulation, or is it some kind of internal company documentation or HR compliance where the LLM responses are evaluated against, or is it some climate impact related compliance, or some company culture maybe the LLM is not responding based on the company culture and this sort of things. So you need to choose your battles and prioritize, but developers and stakeholders and problem owners need to do that, I would say, before building anything. In fact,
that's what I'm about to ask, that you guys work on the already built applications, LLM, or you actually help the young entrepreneurs or basically aspirants before building an application?
We can be our platform can be used in two ways. One, if you are building applications, you are building your applications with your favorite framework. We are agnostic. We are agnostic to any kind of LLM, use LangChains, whatever, we don't care. But we can use our evaluators to, during the building time, hey, is this prompt better than this? Is this model better than this? Based on the metrics, really this high-level metrics I talked about, things you actually care about. So we help in this building stage. We don't build automations for you. So you don't build automations using our tool, but you choose your favorite framework, and with a couple of lines of code, you can compare because you have the measurements. And once you decided, hey, this kind of parameters of my RAG and bot and this kind of metrics I care about, and it performs well, good enough, and this is the model and prompt, you go to production. Then we also evaluate every single response in production and working as a guardrail. So we detect low quality responses. So it's both at the building stage, choosing your design parameters and LLMs and prompts, but also in production, once you decided that it still hallucinates, it still makes mistakes. So we detect those in production real time with evaluating every single LLM response.
So this all makes sense. So many enterprises struggle to move from experimentation to full-scale deployment of AI models. So in your experience, what factors determine whether a business successfully adopts AI at scale?
To my experience, when I look at enterprises that actually went to production and successfully created value with generative AI and large language models, I don't think it's an industry specific thing. There are examples in all industries and lots of examples who couldn't be successful in all industries too. But something I realized is if management, like top decision makers, top management, has the following mindset, then they are likely to be successful. And the mindset is this: we will be automating 20% or 10%, whatever, of the tasks we are doing completely end to end. If the management is this completely end to, we are doing like thousands of tasks as humans every day in our organization, and this 20% we will completely automate end to end. And most companies who fail to go to production, they have the wrong mindset, which is this: okay, we will still do all these tasks, but with LLMs a bit faster. So they don't have this complete automation mindset, because if you are still doing all these tasks, but still a human has to check things, that's still a human is the bottleneck. So if you have the mindset, no, we will completely end-to-end automate these tasks, and that's our goal, then they start to ask, okay, but end-to-end automation, complete automation is scary, of course.
True.
Like,
Yeah, that's my point.
then you need to, hey, then we need to measure this. We
Yeah,
can't just turn it on, and then it clicks. Oh, we need to evaluate.
yeah. But anyway, what do you think? The role of humans would be over then if we have evaluators of LLMs. So they are also humans, right? Humans are evaluating LLMs somewhere, somehow.
Yeah.
They have created this evaluation mechanism or metric. So what do you think? What would be the role of humans as far as this evaluation is concerned?
I think human in the loop is important in the sense that there's a lot of this kind of tacit knowledge and hidden context that's not in your documents, but you just know because it's common sense sort of knowledge. And the LLM might think, oh, it hallucinated because it's not in your documents, but it's common sense that if I drop this, it falls. So it doesn't have to be in the document. So so there's a lot of this kind of corrections to those cases where LLM is just can't grab the context, and it's super contextual, and it is kind of that sort of thing. Human maybe nudging or corrections will be quite important. And another thing with, I think, human evaluation is just designing and deciding and defining the metrics. Hey, this is the high level metric we care about, very detailed. This is my intent. This is an expected input and output from this automation. And that is a very human thing, because humans know the context, human knows the domain knowledge, human knows what can go wrong. Like, ability to define it in a structured and systematic way and turn it into a metric and evaluator. That is really that's very human thing. That it's difficult to automate. So that's how I see it. Just defining the metrics, complex metrics your business or your automation cares about. I think that will be driven by humans for a long time.
The landscape of AI evaluation is evolving rapidly. What trends or technologies do you believe will shape the future of LLM evaluations? And how do open source evaluation repositories impact this space?
Yeah, I think one big paradigm is this LLM as a judge paradigm, which we also believe in. So if you can implement it properly, large language models are in fact able to assess and evaluate other large language models. It's not there are a lot of details to this. So asking GPT-4 to evaluate itself, it has this bias, and there's like, it's not that simple. But if you can train your own custom models, LLMs as judges, to perform that specific evaluation, lots of research, also in our research, we show that it is very correlated with human judgment. So this LLM as judge, like automated way of evaluating with other LLMs, I think that's one big paradigm that will change also how people evaluate things. And the second question of open source tools, I think there are lots of course, open source tools to do this. Um, they are a bit they care more about a bit lower level metrics, and those metrics are a bit far away from
Very
business.
generic.
So that's my experience.
So, talking about the LLM's partnership with media companies, OpenAI has just recently partnered with major media companies like News Corp, Excel, and Vox Media to access large data set of news articles, of course, to train their AI models. So, how these partnerships aim to enhance accuracy and quality of LLM's output?
I think this partnerships are um, they just make data collection, high quality data collection easier, because if you scrape the web, there's all sort of noise that's coming with it.
Yeah.
But when you immediately partner up with the content creators, you are getting clean data without anything else from the get-go. So that's one thing. So there's the data quality will increase, which will increase the, of course, large language model performances.
Makes sense, makes sense. So, do you believe do you have any personal experience or case studies related to deploying and scaling LLMs, and you would like to share with us?
Yeah, we are building because our evaluators are LLMs as judges, so they are LLMs itself,
All right.
meaning that we need to scale them when lots of requests are coming. And there are a bunch of ways of doing it. Some tips are like quantization is pretty helpful. So you don't want to host a full precision of 200 billion model or anything like that, because with just very little loss in accuracy, almost no, you can quantize the weights and have several times faster model with much less latency. And this is very common, maybe thing to scale. Another thing is, nowadays the same model you can be hosted by many all kinds of providers. Let's say open source Llama 3.1. You can host it yourself in your own GPUs in your office. You can host it in Azure. You can host it in AWS. There are a lot of third-party providers hosting it for you and charging you. It's an open source model, but they are still charging you token-based, tens of those, meaning that you can dynamically route your requests. If you hit rate limits in certain thing or hardware limits, you can use this other thing of the it's the same model. Even with proprietary models, you can use let's say Claude models from Anthropic, directly from Anthropic, or through AWS Bedrock. And so you can really scale, if you have the correct routing and proxy, you can scale in that sense that you can avoid rate limits and token limits and things like that if you implement it properly. So that would be my two tips.
We've seen interesting topics like you have already mentioned self-improving AI systems and privacy-preserving AI. How do you see these trends aligning with the future of LLM development and, of course, evaluation?
Yeah, privacy preserving AI is pretty interesting topic, because you can do this kind of federated learning stuff. It's just really slow, but you can do it, if you really care about that. So that's one. That's, I think, quite open research topic, and it will be more relevant for certain applications, typically healthcare, I would say, when there's this lots of clients distributed, and you don't want to share models and anything like that. You just want to you want to train a large model collectively without sharing the model, but you're just sharing the model weights or updates to the model weight. So this sort of things. So I think maybe LLM evaluation sense, this is not that relevant, but what is relevant is that evaluation of if the LLM is, if your application is leaking any confidential information or personally identifiable information, PII, you want to catch that before showing to the end user, and you need a confidentiality evaluator, which we have, and it's like a guardrail around your applications. So that's one way to. LLMs will still make mistakes, but you can catch it. So that's one way to preserve privacy in that regard.
Okay, thank you so much for your time, Moz. Looking forward to seeing how your insight and expertise continue to shape the future of AI. Thank you so much.
Thank you. Have a nice day.
Bye bye.